declarative. This is also another name given to the non-procedural. Only declare what is required without mentioning how to retrieve those data. So that's why procedural. This mentions how to retrieve those data and what data is required. But as in case of non-procedural, we are only giving which data is required without specifying how to retrieve those data. So there are some pure languages, that is a theoretical languages are there: relational algebra, tuple relational calculus, and domain relational calculus. So these are the three languages which are used for these are the pure languages based on which there are a number of implementations are there. So it means, and these three are having the same computational capability. Computational capability, it means which operations they can perform. So what is the power of relational algebra? The same is the power available for the tuple relational calculus and domain relational calculus. So in this chapter, we are going to cover all of this, but in much more detail, we are going to cover relational algebra. And whatever SQL language is there, this SQL language is a combination of this relational calculus and relational algebra. It means SQL language. This is using a model based on this relational algebra and relational calculus languages. And SQL is also one of the practical implementations of non-procedural languages. So let us move towards the next topic. So throughout this our discussion, we are going to use the schema, that is classroom. First relation is the classroom. Within that we are having building and room number and capacity. These are the three attributes. So within that also building and room number, this combinedly forms a primary key. Primary key to uniquely identify any tuple or any entity or any record from a table. So within that, whatever building and room number combination is there, this combination will be always unique in case of this complete relation, that is a classroom. Next, we are having department. Within a department, we are having department name, building, and budget. Next, course. In the course, we are having course ID, title, department name, and credits. Next, in the instructor, we are having ID, name, department name, salary. Section, course ID, section ID, semester, year, building, room number, time slot ID. Again, teachers is one relation, student is one relation, text one relation, advisor, time slot, and prerequisite. So here, this is the regarding the physical infrastructure. Department gives information about the each department. Course, this relation gives information about the all the courses, or subjects taught in the every department. So here, this is going to cover every department and every course covered during the covered or yet to be covered during the department existence. And next, instructor. This is giving information about the which instructors or which teachers are available. Section. This section is giving the history. History, it means that when this course was taught. Course, let us take an example of the database engineering. Database engineering was previously taught in the third year, second semester, and this was the changed in 1920 and taken to the first semester. Okay, that is a current scenario. It means in the previous scenario in 2003, in 2004, this might be covered in second year, or this might be covered in the first year, or this might be covered in the last year also. It means anyway the syllabus is going to change and structure also going to change. So the section is covering which course has been taken in which section, and there is also a semester pattern within the each section. Just like I am having first year, second year, and third year or final year. So sec will give me 1, 2, 3, etc. Semester gives me autumn, fall, summer, etc. These are the combinations. Year, which year, 2009, 10, or 19, 20, 30, etc. building, in which building this was taken, in which room number this was taught, and at what time this was taught. It means during the throughout the day, at which time slot this subject used to be taught. So this section is holding this information. Then teaches, it means that here whatever this section taken in this building is there, who which teacher has taught this subject. So teachers, this is holding the information previously whatever the subjects were taught, who has taught this subject with respect to the id. So here we can see that course id, section id, semester and year is a primary key of the section, and this is being referred into the teachers. Again, this is underlined here. It means this primary key is also a part of, this primary key is foreign key into the teachers, and also this is not a complete primary key. Here id is also part of primary key because id is also underlined here. It means that this complete relation will hold only or will be a primary key. This is a composite primary key, and hence whatever this id is there from the instructor is acting as a foreign key in the teachers. And similarly another relation with the students which will hold the information about the students, takes, this takes, it means that here again that which student has taken this id and what is the grade allocated for that subject to the student. So here we are storing the marks of the students. Okay, grade, it means here any grade we can take a b c d up to e etc. And if student has appeared for this course into the previous section, which grade has been allocated to the student. Next, advisor, it means here this which student is guided by which instructor. Time slot id, here time slot, it means that throughout the day we can have any start and end time. Just like right now our lecture started at 1 p.m. and will end up to 3 p.m. So it means that here today is a Friday and start time is 1 p.m. End time will be 3 p.m. and time slot id, first section, first session, second session, third session, any time slot id will be there. So this is how this information is being stored. And next prerequisite, it means that for learning particular subject, which subject is acting as a prerequisite. It means requirement. Just like for studying database, advanced database system concept, I need to study the core database system. So it means database systems becomes prerequisite for learning the advanced concept. So that is a prerequisite subject. So this is the complete schema, and the same schema we are going to use for explaining the remaining concepts of this chapter, relational algebra, as well as for the SQL. Some other examples also we might take, but this is the most probably used schema. Schema where I am mentioning which rows will which tables or relations will be there, and what are the columns in that every relation will be there, and also which are primary keys and which are the foreign keys. So this complete information is given here. Now let us see which are the operations, relational operations we can perform. So we can perform a number of operations. Am I clearly audible? Am I clearly audible?
Yes, ma'am. Yes, ma'am.
Okay. So let us start with the relational operations. So relational operations, these are the, it means here whatever procedural languages are there, for that we can have number of operations. So we are right now talking about the relational algebra. Let me use the mic. Clearly audible? Hello? Clearly audible?
Yeah, ma'am. Your voice is getting.
So, okay, let us go for the continue with the explanation. Relational operations. So, relational operations, it means that which operations we can perform onto the each of the relation. Relation refers to the table. So, all procedural relational query languages provide a set of operations that can be applied to either a single relation or a pair of relations. So it is not always compulsory that we should always retrieve data from only single relation. Up to now, we have seen just like instructor relation, we have seen department relation, we have seen. So it is always not mandatory that we should go for only single relation data to be retrieved. We can go for retrieving data from one or multiple relations also. So for this purpose, we are having number of operations allowed. So here main thing we should remember is that always whatever data we are retrieving, that will be returned to us as a relation only. Relation only, it means that if I am willing to retrieve those students data who has taken database engineering into year 2019, okay, or I wanted to know those students for whom grade was A for all the subjects or for database engineering, then here it means that here whenever I am asking for the information, whatever information given to me as output from the database is there, this is always in terms of a relation only, that is a table format only. So this is the main property. And here we might give number of relations as input, but always only single relation is given as output. The same point is given in the second point. The second point says that these operations have nice and desired property that their result is always relational operation is there, that is always a single relation. So here most of the operations we use within that there are two things considered, that is we are applying some condition and we are selecting few of the columns. For example, okay, I will use this instructor relation. Okay, this is my instructor relation. Now consider that I wanted to list those faculties, details of those faculties whose salary is greater than 60,000. Okay, or let us take 65,000. That is my requirement. So in that case, whenever we are trying to retrieve, so this whatever query statement I will say that retrieve the information about the instructors who are having salary greater than 65,000, then in that case whatever the statement we are giving, that will be into the higher level language, and we will write an equivalent query for that statement. So here my requirement is that salary should be greater than 65,000. So whatever condition it means first thing is that I do not want to list all the instructors. Only I am interested in those instructors who are having salary greater than 65,000. So this salary greater than 65,000, this becomes my condition, or this is also called as a predicate or any condition, or we can say that this is a filter we apply onto the relation. For example, I will say that the first tuple Einstein physics 95,000, this qualifies the condition, that is condition is true that salary is greater than 65,000. This tuple will be in the output. Second tuple or second record will be also as a part of output. The third tuple, that will say history 60,000. This tuple doesn't satisfy the value that payment salary is greater than 65,000. Here I can say that salary is 60,000. So this entry that ID 32 34 3 ill said and history and 60,000. This tuple will not be a part of my output. That care or that restriction or that filter of salary greater than 65,000 will be applied here, and only those tuples or record which satisfy the condition that will be only given to me as a output. So let us see which are the other things given in this relational. So here the most frequent operation is the selection of specific tuples from a single relation. So here we are selecting only specific tuples. We are not selecting every record or every tuple from the relation, but we are selecting only selected tuples or rows. So here relation taken is instructor from a single relation, say instructor, that specifies some particular predicate. Predicate, it means this is a condition applied. Say salary greater than $85,000. Okay, this is the condition that salary should be greater than $85,000. The result is a new relation that is a subset of original relation instructor. So here, whatever the complete relation or out of complete relation, those tuples which are satisfying this salary greater than $85,000, only those tuples will be listed here. So let us again go back to the previous relation. So here we wanted to select only those instructors who are having salary greater than the $85. So first tuple qualified, second qualified, 75 no, 80 no, 72 no, this no, no, 92 qualified and 87 qualified. So these are the tuples which have satisfied the conditions. So I want this 3, 3, 4, 5, 6 gold physics 1, this 2, 1, this 2, then this 3 and 4. Okay, total 4 tuples which are satisfying this condition are found. So let us see whether in the output I am having the same 4 tuples. Yes, I am having the same 4 tuples, that is 90,000, 95,000, 87,000 and 92,000. So these are the only 4 tuples which are satisfying this condition. So similarly, we can apply condition on any of the attribute. It is not fixed that we should go apply a predicate or condition onto the salary or any integer value. We can apply any condition on any of the attribute. The thing is that the attribute should be operation compatible. It means within the salary, if salary is my integer, I cannot compare this with the alphabet, etc. So that here we should take, or any alphabetical attribute is there, just like name. In the name, I cannot check whether name is greater than some 90 or 65, etc. That condition we cannot apply. So here, whatever operation we are applying, that should be type compatible or matching with the given type. So here, for example, the same that salary is greater than 85,000. We result is shown here as a fourth point. Okay, clear with this specific operation that applying a predicate and giving the result. Yet we had not started query writing. So let me know if you are facing any problem. Are you facing any problem? So let us start with the next point, that is the relational algebra. Relational algebra, this is a procedural query language and it consists of set of operations that take one or two relations as input and produce a new relation as their output. So the same point we learned previously also. The fundamental operations in relational algebra are select, project, union, set difference, Cartesian product and rename. So these are the basic operations or fundamental operations in the relational algebra. in addition to this, we are having other operations also. That is set intersections, natural join, and assignment, and union, etc. Many more are there. So let us first go for the fundamental operations. So fundamental operations are select, project, rename operations. These are called as a unary operations because they operate on only single relation. So as it says, it consists of set of operations that take one or two relations. One, it means input can be only single relation or input can be multiple relations. So fundamental operations are select, project, rename. Operations are unary operations because they operate on one relation, and other three operations operate on pair of relations, and these are that's why called as a binary operations, that it is having two relations as input or multiple relations as input. Unary operations perform only on single relation and binary operations perform on multiple relations. Let us see each of these operations one by one. So first, select operation. Select operation here. This right now we are talking about the relational algebra. So those diploma holder etc. please they might have learned this select operation in case of SQL. Please don't get confused regarding this select operation. Right now we are talking about the relational algebra only, and here select operation is used in order to filter some tuples or select only those records which satisfy some condition. Okay, so here select operation selects tuples that satisfy a given predicate. Predicate, it means condition. We use lowercase Greek letters sigma to denote the selection. So for giving the selection, we are using a sigma symbol. The predicate appears as subscript to sigma, and the argument relation is in the parenthesis after the sigma. So here, whatever condition we wanted to apply to the given output, we can pass it as a subscript to the sigma, and next to that we can pass in brackets the relation name on which we wanted to apply this condition. So let us see what is the example for this. So here, consider that my requirement is that to select those tuples of the instructor relation where the instructor is in the physics department. Okay, so here my requirement is that to select those tuples, those records of the instructor relation where instructor is into the physics department. So here physics department, it means that this physics value belong to the physics department name. Okay, so in the instructor relation, do we have any column with name department? No, we have four columns: ID, name, department name, and salary. If I'm saying that instructor is belonging to the physics department, it means that clearly I'm talking about the department name attribute or department name column. So here we should apply the condition that whether department name is equal to the physics. So let us see the original relation. Instructor. Okay, this is my instructor relation, and within that I wanted to find out only those tuples where department name is physics. I'm not interested in other instructors. So here I should apply the condition that just like previously I have applied salary greater than this 85,000. Now I wanted to apply the condition that department name should be or department should be physics. Then I clearly understood that department is nothing but a department name. And now we should apply the condition. So let us see how many tuples are there which satisfy the condition as physics department. So this is the first entry, Einstein physics, with 5 times 2 as ID. And one more. Yes, here gold is also belong to the physics department. Any other entries here? Whether slides are clearly visible to you? So here there are two entries. One Einstein and another Gold. These two are the instructors which belong to the physics department. Now let us see whether we can move to the So let us see how to write a relational algebra query. So relational algebra query is written. So relational algebra query is written. So here we are demonstrating how to select only those tuples which satisfy the condition. So here I wanted to list tuples from the instructor relation. So here in the brackets I will pass the instructor relation. So the select operation says that the argument relation is in the parenthesis after the sigma. So that's why here first let us write a condition or predicate. So predicate says that we should have a physics department. So sigma symbol, a select symbol. Next, department name equal to physics. This is the condition which we wanted to apply. And after sigma, we can pass the instructor as a relation name in the parenthesis or in the brackets after the sigma. So this is how we are writing the query. Okay. So now let us see how to write a query for the previous statement. Previous statement was here if we select tuples from the instructor relation of figure and satisfying the predicate salary is greater than 85,000. Okay, this is my requirement. So in that case, how we can write the query? Any idea? Yes, can anybody give me how to write the query for this?
Ma'am,
Yes.
ma'am. By using where clause, we can write the salary query like salary is greater than where salary is greater than 60,000 or 80,000.
First question, had I used anywhere where?
No.
Then
Then select. Sorry. Select sal equal to uh, what we can.
yes, exactly. So here we are passing predicate by using a sigma symbol. So here sigma symbol only we can pass. It means right now whatever this sigma is there, this is read as a select here. So select, I will copy the same query and will change as per our previous requirement. So here this condition is not based on to the this column, that department name. Here my predicate is based on to the salary attribute. So salary, this is my separate attribute and department name is a separate attribute. And here salary should be greater than $85,000. So I will use the same 85,000. Done. And as I'm having the predicate onto the same relation, so instructor can be given as it is. So clear with this?
Yeah, ma'am. Now it is clear.
Okay, shall we go for one more example by taking some another relation?
Yes, ma'am.
So okay, actually department relation is not given here. So I will list only schema. Department, this is the relation name which is having attribute like department name, building and budget. Okay, these are the attributes of the department building. Now I wanted to list those departments which are there in the second building. Okay, so okay, this is my requirement that the department should be available into a second building. How we can write the query here? How we can modify the current query to satisfy to the given requirement? that here whatever department I am talking about, give the department tuple which is there in the second building.
Uh, Ma'am,
Hmm?
sigma
Huh?
department equal to second building.
Department.
Sorry. What? Ma'am, repeat the question. Repeat the question. I will tell you.
My requirement is that list those department tuples
Okay.
which are located into second building.
Mm, sigma second building. Ma'am,
Hmm?
sigma second building equal to uh, department name.
Okay, we will come to the first this very answer. Okay, here whether value is given at the start or column name is given at the start. Here whether this department name is a column or value.
Column.
Column. It means that here whenever we are passing the condition, always we should pass column name as a value. Just don't use any of the comparison operators. Okay, and that's why here second building, let us assume that it means where this value can be. Second building can be value to whether department name. No, my department name cannot be a second building name. Next, whether second name, this value can be applied to the building. Yes, building can be second building also. It means that the possibility of having to the building is possible. This value cannot belong to the department name. Okay. My question was list those departments which are there in the second building. Okay. Second building, this value can be applied to the department name. No, this cannot be applied because department's name are having another department. It means civil engineering or physics or whatever departments we have got. Building, this attribute can take the value as second building. And that's why here, whenever we are passing the predicate, first we should apply a column, okay, on which we are going to check the attribute. We are going to check the predicate that building should be equal to the second building. Second building, as this is a alphabetical value, that's why always enclose this into double inverted commas, and whenever there is an integer value you need not to enclose this into the single or double inverted comma. But whenever alphabetical value is there, always this should be enclosed or this should be considered as a string. As physics is a string, 85,000, this is an integer value. And column name, you need not to mention this as a whether this is acting as a variable into the programming language. Just like if I'm writing int a, okay, int a if I'm writing, so I need not to mention that a is a variable. Even though if I'm saying that character a, okay, character a, still I will use a as it is, and if I wanted to assign any value, I will apply this value to this a by using single or double inverted commas. And if I'm having a as an integer, okay, a is the integer, directly I will pass the value. The same condition or same theory we apply to this uh, relational algebra also. Whenever there is a alphabetical value, we enclose into double inverted commas, and whenever there is an integer value, we write the value as it is. And we can use here any comparison operator, just like less than, greater than. And in case of alphabetical value, values, we are having some restrictions. So here we can go for equal to symbol for checking, selecting those tuples which are satisfying the building value as second building. And right now we are applying the query onto the department relation. So here there should be a relation name as department. Clear? So this is the query. Select building equal to second building from department relation. That is how we are writing this query. Shall we go for one more example?
हॅलो
Yes.
मॅम तुमचा आवाज कट होते मधून मधून
हो का?
Yeah, ma'am, your voice is breaking. Means, and while teaching, means it was gone for few seconds.
Okay. Whether my explanation is audible to you?
Ma'am, this is last example I had listened, but what you told department, that means relation, from the relation onwards it is gone on my side.
Okay. Let me check through the machine. From the machine also this is not clearly audible to you. Now whether it is clearly audible to you? Now?
Yeah, ma'am. Now it is getting. It's
Okay.
raining now, so that caused problem in network.
No, actually, simultaneously I'm using cell phone for checking the audibility. I can listen properly.
Then there is a might be issue on our side, ma'am.
I actually am receiving in the chat window number of students saying the same. Okay, let us proceed. So here I was talking about the second building. Second building. Okay, I will take a relation from the department only. Wait for a minute. So, okay, whether this relation is visible to you? Whether this relation is visible to you?
Yes, ma'am, it's visible.
Okay. Uh, so here, here we can apply much more conditions. So here, consider that I wanted to list only those subjects, or I wanted to list details of those subjects which belong to the computer science department. Okay, that is my condition, that there might be 17 to 18 subjects are there into the course relation, but out of that I do not want to display each and everything. I only wanted to display those subjects which belong to the computer science department. Okay, so right now what is my query? Query, uh, list departments or list courses, course tuples which belong to computer science department. Okay, okay, that is my right now condition. So here condition is based on to this computer science value. Okay, this is my value. So now here, along with the same, I have given that this should be belonging to the computer science department. So let us take what is the schema of the course relation. So course relation says that I'm having course ID, I'm having title, department name and credit. So let us check right now in the query. Clearly it is mentioned that computer science department. So computer science, this is the condition which I wanted to apply onto my relation to be displayed. Here the first question comes, am I interested in displaying the complete relation? No, we do not want to display the complete relation. We only wanted to list those tuples or those records where the department name equal to computer science is there. So here belong to department computer science, that is given. It means that this value computer science department, this is available into department name column. So this, on this column I will apply my condition. So here we can apply the condition by using this, that I wanted to apply condition that here predicate we wanted to apply. So predicate is based on to the department name. Department name and whether department name, am I saying that clearly I need computer science? Yes, I clearly saying that I need a department name to be computer science. So here I will use the same name for giving the information. And right now what is my relation name? Course is my relation. So here instead of instructor I will use course. Done? Done? Audible? Audible?
Yeah, ma'am, it's audible.
Whether the query is clear?
Yeah, ma'am, it is clear.
Okay, shall I give one more question to you?
Yes, ma'am.
Okay, now my requirement is that here I wanted to list details of those subject other than the computer science department. Okay, I wanted to list those subjects which are taught in the other departments other than the computer science. So how we can write the query? How we can write the query for those subjects which are being taught into the other departments than.
We can give the condition of not equal to like
Yes. Here
uh,
instead of this equal to, we can apply the not condition also. Okay.
yeah.
Not equal to condition also we can apply.
Because ma'am, if we are like department equal to biology, then we have to write multiple query for that. So the thought came in my mind, we have to apply not equal to. Then all are listed.
Yes, yes, yes. And there can be, it means right now there are, it means 7 to 8 departments are there, and it might happen that I may not be able to list all of them. If I don't need only computer science and needing or remaining, then we can go for writing the remaining, no problem. Okay. The query is right that we can write the uh, not equal to symbol and get those tuples which are having the uh, it means those tuples which other than the computer science department, no problem. So clear with this query, clear with the first operation.
Yeah, ma'am, it's clear.
Okay, anybody else is facing any problem regarding this select operation? So here right now we are covering the select operation of the relational algebra. Don't mistake this as a operation of the SQL. SQL select is having different meaning, and this select only belonging to the relational algebra. Okay. So this is it means just coincidence that during designing the SQL select keyword is used, and it is just a history that two keywords are similar but are having different perspective into the relational algebra and SQL. So okay, let us go for the next query. Next slide. In general, we allow comparisons using not equal to, less than or equal to, greater than, and greater than or equal to in the selection predicate. It means we can apply any of these conditions or comparison operators for selecting or applying onto the tuple, and we can combine the conditions. It means more than one predicate into a larger predicate by using connectives. Connectives like here, this is a and, this is a or, and this is a not. Okay. So the statement says that furthermore, we can combine several predicates into a larger predicate by using connectives and, or, and not. Okay. For example, if I'm saying that I wanted to list those subjects which are taught in computer science but with the credit 4. Okay. My condition is that department should be computer science and credit should be 4. Such subject only I wanted to list. In that case, whenever we are having condition on more than one department or more than one attribute or more than one conditions are there, then we can apply this condition by using a and, or, not, etc. So here this is one condition that department name should be computer science, and then we can use the predicate as and. Here we will use a predicate and then apply the given another condition that credit should be equal to 4. Okay, this is how we are applying the condition. So it's your wish to pass the brackets or not. It is not always compulsory to pass the brackets, but to differentiate between the conditions, we can use the brackets also. It means here bracket 1 for the first condition and bracket 2 for the second condition. So let us see which are the much more statements. So this is one of the examples given into the slide already by author. So here relation R is given, A, B, C, D. These are the 4 attributes. And here condition is that A should be equal to B and D should be greater than 5. That is the condition. So relation R is given. So here first condition is A equal to B should be there. So A equal to B. I am having the first tuple qualified to this condition. third and fourth. These three tuples are satisfying the first condition, that A should be equal to B. A should be equal to B, A should be equal to B, and A should be equal to B. And second condition says that D should be greater than the 5. So here random D I cannot check to anywhere. I should check only those tuples which are satisfying the first condition. First condition is satisfied by the first, third and fourth tuple. Now apply the second condition on these tuples only. So here D is greater than 7. D is greater than 5, that 7 is greater than 5, condition satisfied. So first tuple will be added to the output. Second tuple we are not considering because here A is not equal to B. And next come to the third tuple. A is equal to B, yes, but D is not greater than the 5. D is less than 5. So whatever this condition is there, this gone wrong, that D should be greater than the 5. So again we disqualify this tuple, remove this tuple, and the last tuple is beta beta. Yes, both are equal, A equal to B, and D value is also greater than the 5, and hence there will be two tuples in the output, fourth tuple and first tuple. So only those two tuples are the part of this output here. Okay, clearly audible? Clearly audible? Condition is clear. How we can pass this? Please understand these concepts now only, else whatever our SQL is there, this will also become difficult to understand. Okay, if we are clearing our conditions and how to select tuples and which can be the output, if we are clearing now, then it is very easy to understand or write the queries into the SQL, etc. Okay, so if you are clear, we can move to the next operation, that is project operation. If you are having the queries, let me know. So okay, as we have studied this select operation, I want you to read this one more time and then for a minute, and then we'll go for the next operation. No queries? Now let us start with the next operation, that is a project operation. So here up till now, whatever we have learned, that this example or this example, we are listing the complete tuple. It means all the columns we are listing. Here also we have listed all the columns. So it might happen that during the query, I may not be interested to give all the details. If I once given the query that salary should be greater than 85,000, I only wanted to know that instructor's name should be displayed, not other attributes. Or I wanted to display ID, name, and salary, and right now I'm not interested to displaying the department name of that instructor. So it means other details may not be required for me during whenever I'm firing the query. Okay, that can be a condition. So for this purpose, we are using a project operation. So project operation says that we are selecting a columns or attributes. Selection of columns or in bracket attributes is there. So let us read the explanation. So Suppose we want to list all the instructors ID, name, salary, but do not care about the department name. Okay, suppose we want to list all instructors ID, name and salary, but do not care about the department name. So in this case, the project operation allows us to produce this relation or whatever output. The project operation is a unary operation. Okay, unary, it means can be applied onto a single relation. Unary operation that returns its argument relation with certain attributes left out. Certain attributes left out. It means we are removing or filtering few of the attributes. Since our relation is a set, any duplicate rows are eliminated and projection is denoted by uppercase Greek letter pi, and we list those attributes that we wish to appear in the result as a subscript to pi. Okay. So here we are having the query. We want to list all instructors ID, name and salary. We do not want to display department name. So this is how we wanted to display our relation. So for this purpose, we write the query to produce such a list as pi, and to subscript to that list those attributes which you wanted to display. Here I wanted to display ID, name and salary, and these are the attributes of the instructor relation. So instructor should be in parenthesis, displaying that we are going to display the tuples or records from the instructor relation. Okay, so clear with this. Here department name, this arrow, column is not available. So if consider, I say that if my requirement is that I wanted to display ID and name only, I do not want to display salary, then how we can write the query here?
Projection ID and name only.
Yes.
And projection means that symbol ID and name only, and relation instructor.
Yes, here we can pass this query as like this. Visible now? Here, if I wanted to list only ID and name of the instructor, only list those attributes to the pi or project operation, and later on give your relation name. Done. Simple operation. Okay, let us go for another example. So here, relation R is given. Relation R is given. So within that, if consider we are willing to list only A and C attribute, okay, not willing to display B attribute. In that case, here we are applying the condition. We are not applying any of the condition onto the tuples for filtering, but we are displaying or listing those attributes here, pi, A and C, and then displaying those. So if consider B is getting removed, then we are having A and C. First tuple alpha and 1. Alpha and 1 will be there. Second tuple alpha and 1 will be here. Alpha and 1, beta 1, beta 1, beta 2, beta 2. So okay, this is the complete relation, or this is the complete output which we will get as an output. But here alpha 1 and alpha 1, this is getting repeated. So whatever the relation is shown, this is always acting as a set where duplication of the elements is not allowed. And for this purpose, whether we are writing alpha 1 once or twice or thrice or many times, this is not going to make the sense. And that's why here whatever duplicates are there, alpha 1, that will be get removed here. That is, duplication of this alpha 1 will be merged into a single output alpha 1, and then we will have only three records displayed as a output here. Simple operation, projection. Shall I give one more example to you? Okay, consider that I wanted to display only titles of the subjects. Consider that I wanted to display only titles of the subject. Then how we can display simply titles?
Ma'am,
Hmm?
projection and only give the title.
Huh?
Yes, is it?
And what about the relation name?
Uh,
Yes.
subject.
Relation
Hello.
name is also required, and title should be as a subscript to the pi. Okay.
Yeah.
Relation name, do not forget to give the relation name always as an not subscript but next after the this clause. Okay. So this is how we are writing the condition. So if I wanted to simply list those tuples which I wanted, it means only title if I wanted to display. So here I will use the symbol pi. So let us take, I'm writing pi because I need to go to the symbols and then select the pi. So instead of that, I will use the word pi, and to that I wanted to select only title. So here title will be there, and in bracket course will be there. So course is my relation name, and whatever title is there, that should be subscript. That should be subscript to the pi, mentioning that from this course relation, we wanted to only display the title. Yes, your answer is right. Now we will move to the much more next difficult, not difficult, but the further concept. Next concept is regarding composition of operations. Okay, it means right now we have learned selection as one operation, projection as one another operation, and if you wanted to combine these two operations, so here my query is that find names of all instructors in the physics department. Okay, here the main is that I wanted to display only name. Previously we were displaying complete tuple. Okay, now I wanted to display only name. So name, it means that to the pi I will assign the name of all instructors in the physics department. So physics department, again I wanted to give filter to the tuple value also. So whenever we are writing such conditions which are involving more than one operation, that is sigma also we wanted to apply, and we wanted to apply project operation also. And that's why here whenever we are writing such operations, we always enclose these into the brackets. So first is that, so let us understand how this flow gets applied. Okay. So here first condition, we wanted to perform pi operation, that is project operation also we wanted to perform, and we wanted to perform select operation also. Okay, this is my requirement. So my question is, shall we perform first project operation or shall we perform first select operation? If consider we only taken project, okay, simply let us understand that we first select a project operation. So project operation will only give me names of all the instructors. Okay, this is going to give me simply instructor names. So now on the project operation, if I'm having the name, can I apply the condition of department name? Question is clear? Question is clear?
Ma'am, repeat the question.
Question is that we wanted to perform project operation also, and we wanted to perform select operation also. Okay, so if we consider that we first perform project operation. Project operation says that find the names of all instructors. So from the instructor is having ID, name, department name, and salary. These are the attributes. And if we first perform project operation will return me all the names of the instructor. Now my question is that on the names after performing the project operation, can we apply the select operation? Yes. कळालंय का question? Have you understood the question?
Yes, ma'am, it is understood.
Now आता समजा मी फक्त नेम जर सिलेक्ट केले याच्यातून, सॉरी आय विल गो टू दिस रिलेशन. ओके, ही माझी रिलेशन आहे आणि या रिलेशन मधून समजा मी प्रोजेक्ट ऑपरेशन अप्लाय केलं आणि फक्त नेम्स जर घेतले तर मी कंडिशन अप्लाय करू शकते का की डिपार्टमेंट नेम इक्वल टू फिजिक्स असायला पाहिजे म्हणून? एकदा जर फक्त मी प्रोजेक्ट करून नेमच फक्त जर कंप्लीट रिलेशन मधून जर सिलेक्ट केलं, म्हणजे हे नेमचा कंप्लीट कॉलम मी घेतला, मग त्या नेमवर मला कळू शकतं का की कुठला कुठला फॅकल्टी डिपार्टमेंट नेम इक्वल टू फिजिक्सचा आहे?
नाही कळत.
नाही कळू शकत. सो द सेम पॉइंट आय वॉन्टेड टू मेक that if we first perform project operation, म्हणजे समजा आपण प्रोजेक्ट ऑपरेशन जर केलं, प्रोजेक्ट ऑपरेशन केल्यानंतर मला फक्त तोच कॉलम लिस्ट होईल जो मला डिस्प्ले करायचा आहे. अशी कुठलीही कंडिशन मॅन्डेटरी नसते की तुम्ही त्याच कॉलमवर तुम्ही कंडिशन अप्लाय केलेली पाहिजे, नाही. हिअर माय कंडिशन or whatever my predicate is there, predicate is based on to the department name. Okay, predicate is based on to the department name. इथं एक तुम्हाला you must understand that select this is a filter for complete relation, आणि जे काय माझं सिलेक्टचं आउटपुट आहे त्याला हा फिल्टर करतो. फिल्टर फॉर सिलेक्ट ऑपरेशन. ओके, filter for relation or filter for tuples, and whatever project operation is there that is a filter for select output. म्हणजे पहिल्यांदा सिलेक्ट ऑपरेशन आधी करावं लागतं मला. सिलेक्ट ऑपरेशन मधून जे जे टपल्स डिपार्टमेंट नेम इक्वल टू फिजिक्सला सॅटिस्फाय होत आहेत ते टपल्स घ्या आणि त्या टपल्स वरूनच मला नेम डिस्प्ले करायचं आहे. दॅट इज द मीनिंग ऑफ दिस क्वेरी. फाइंड द नेम्स ऑफ ऑल इन्स्ट्रक्टर्स इनटू द फिजिक्स डिपार्टमेंट. मग याच्यामध्ये मी प्रोजेक्ट आणि सिलेक्शनचा सिक्वेन्स आय कॅनॉट चेंज. First, I need to apply the condition that all should belong to the physics department. So it means select clause should be first applied and after performing the selection. So select is used for filtering the tuples. Whatever table completely we have, on that table which records to be given for the output, म्हणजे सगळ्याच्या सगळे मला रेकॉर्ड घ्यायचे नाही आहेत. कुठले रेकॉर्ड घ्यायचे ते फक्त सिलेक्ट क्लॉज डिसाइड करतो. कंप्लीट रो. ओके, it won't decide any column or any row or any specific record. या कंप्लीट रिलेशन मधून कुठलं कुठलं माझं आउटपुट साठी इलिजिबल आहे ते फक्त मला कंप्लीट रिलेशनवर अप्लाय करण्यासाठी मला सिलेक्ट क्लॉज लागतो. मग सिलेक्ट क्लॉज चेक करणार डिपार्टमेंट नेम फिजिक्स आहे का, नाही. No, at this point I got the condition that yes, this is the only available value for the physics. And again one more value, two values are there with the physics department, and this complete the 5 times 2 Einstein physics and 95 as the first record, and 33456 gold, physics, and 87,000. These two tuples will be the output of select operation. And after the select operation, again we can apply now the project operation. So after performing the selection, we can go for the project. So right now there are two records, one of gold and one of Einstein. And later on from that we wanted to select only name. So now we can select only name. And that's why we are writing the queries like this. First apply the predicate, and after applying the predicate, whatever output is there. See, previously also I given this point that every operation gives a relation. So whatever this sigma department name equal to physics and to the instructor we are passing, this operation result is also a relation with two complete tuples. 5 times 2 Einstein, physics, and 95,000, and second record as 33456 gold, physics, and 87,000. And to that we are applying condition only onto the name. Then from that Einstein and name will be given as a output to us. And hence because of this we will have output like, wait a minute, just a second now. So okay, whatever select is there, this will have the output like this. So actually this is the part of textbook, and as I'm using Ubuntu, this doesn't have a screenshot option. So okay, this will be the output of select class. Einstein physics 95,000 and 33456 gold physics. So this will be the output, and from that we wanted to only select name. So we will select only name, and name will have only Einstein and gold. Okay, that will be only output available. Done. So this name and Einstein, this will be only the part of output will be there. This is how we can perform the composition of the operations. Clear? Am I audible? Am I audible?
Yes, ma'am. You're audible.
Clear with this composition of operations?
Yeah, ma'am. It is clear.
Okay, let us go for the next operation. That is union operator. So okay, before moving to the union operator, please read this for a minute, then we'll go for the next operation. Read. Now let us go for the union operation or union operator. So, okay, union operation is same as that of the set operations. Set operations you might have studied in the number of times in a mathematical subject. So, if there are two sets A and B, and we wanted to perform the union, we use union. It means all the elements of A or B we are combining together, and if they are having something in common, we are removing the duplicates. The same concept we are applying here. So union operator U is used for this operation. Let us read what it says. Union operator is denoted by U symbol and it is used to select all the rows in bracket tuples from two relations or two tables. Okay, so we are combining two relations here. Uh, let us discuss union operator a bit more. Let us say we have two relations R1 and R2 and both have the same columns. So here main thing we should learn here is that whenever we wanted to perform the union, two relations should be union compatible. Okay, we will study what is mean by this concept union compatible. Uh, Come to the current discussion. Let us say we have two relations R1 and R2, both have same columns and we wanted to select all the tuples or rows from these relations. Then we can apply the union operator on these relations. And a note says that two tuples that are present in the both tables will appear once. Here this says that will appear only once in the union set. In short, there can be no duplicates present after the union operation. Okay. So let us take a simple example here. Here, my condition is that relations R and S are there. So both are having the same columns, AB and here also AB. And I wanted to perform the union. Then here, R and S can be combined. So A and B, the number of columns will remain same. Number of columns will remain same. And but the number of records will be the combination of union of these two. Okay. So here, if I'm saying that alpha 1, first list all the records of R, alpha 1, alpha 2 and beta 1. These three records we have listed. Now we wanted to list or combine all the tuples of this yes. So alpha 2 is already available here. And that's why there is no need of duplicating the same record. That's why this tuple will not be added. It means already added is there. So alpha 2 already existing into a relation and then simply we add beta 3. Beta 3 will be added here. So this is how union is performed. So union of two relations is possible if these two relations are union compatible. Union compatible meaning that if I'm saying relation R and yes, then R and S should have same number of the columns, two number of the columns, and respective domains of these attributes also should be matching. Respective domain, here A is there. It should not happen that here I am having the Greek letter as my domain and here I am going for the integer. No, that is not allowed. Here, whenever we are trying to combine or perform the union, first condition says that these two must have the same number of the columns, and second says that respective domains also should be same. Respective domains also should be same. Okay, I will come to the Marathi. म्हणजे असं होऊ नये की एचा डोमेन वेगळा आहे आणि इथल्या एचा डोमेन वेगळा आहे, भलेही त्या दोन्ही कॉलमचं नाव सेम असू देत, म्हणजे ए इकडं कॅरेक्टर आहे आणि ए इकडं न्यूमरिक आहे असं व्हायला नको. whenever we are performing the union, क्या नंबर ऑफ कॉलम तर सेम असायलाच हवे. म्हणजे आर आणि एस एक्झिस्टिंग रिलेशन आहेत का, रिलेशन मधले फक्त फ्यू कॉलम्स घेतोय, दॅट डिपेंड्स. आणि जे जे काय मी कॉलम घेते, समजा इथल्या ए सोबत मी ए कंबाईन करते आणि बी सोबत मी बी कंबाईन करते, मग त्या रिस्पेक्टिव्ह कॉलमचं डोमेन सुद्धा सेम असायला हवं. देन वी कॅन से दॅट द युनियन ऑफ दीज टू इज पॉसिबल. Okay, let us go for an example. Let us take one relation R. Okay, we wanted to perform the union of these two. Department relation घेते मी. Department is having department name. Okay, and this is also having building. Okay, I will take only these two attributes. Two attributes from the department, and in the instructor. In the instructor, I'm taking ID and name of the instructor. So now, do you think that I should go for union of these two? या दोघांचं युनियन करायला हवं का? Can I
No,
write
no, no,
department?
no.
Yes. Department.
Respective domain is different, ma'am. So
Yes, respective domain is different. ID is of type integer value, and also name I cannot combine with the building. हा, अल्फाबेटिकली ते दोघं पण सेम आहेत, मग त्या दोघांना कंबाईन केलं तर काहीच प्रॉब्लेम येणार नाही. म्हणजे कन्सेप्च्युअली सिंटॅक्टिकली काय प्रॉब्लेम येणार नाही, पण त्याचं काही मिनिंग नसणार आहे. आणि आयडी आणि डिपार्टमेंट नेम हे दोन्ही मी कंबाईन नाही करू शकणार, कारण की त्या दोघांचा रिस्पेक्टिव्ह डोमेन सेम नाहीये. So that is then we can say that these two relations are not union compatible. Union compatible, it means same number of the columns should be there and respective domains of these columns should be same. Okay, let us go for the example which is based on the same explanation. So this is a section relation. ओके, ही माझी सेक्शन रिलेशन आहे आणि मला काय करायचंय की एक मिनिट, आय वॉन्टेड टू लिस्ट दोज कोर्सेस, म्हणजे मला ते कोर्सेस लिस्ट करायचे. माझा आवाज ब्रेक होतोय का? एम आय क्लिअरली ऑडिबल? नो? ओके, नाव इज इट ऑडिबल? अंकिता? So okay, consider that I wanted to list those courses, म्हणजे मला ते कोर्सेस लिस्ट करायचे जे स्प्रिंग 2009 मध्ये पण टॉट केलेत आणि सॉरी समर 2009 मध्ये पण टॉट केलेत आणि फॉल 2009 मध्ये पण टॉट केलेत. म्हणजे असे कोर्सेस जे समर 2009 मध्ये पण शिकवले गेलेत आणि फॉल 2009 मध्ये पण शिकवले गेलेत. हाऊ वी कॅन राईट द क्वेरी? समजा मी म्हणलं की फक्त कोर्स आयडीज डिस्प्ले करा, देन हाऊ वी कॅन राईट द क्वेरी? Okay, let us take a query by step. Okay. Here, my requirement is that list. Okay, course ID. Course IDs which are taught in summer 2009 or fall 2009 or both. Okay, that is my requirement. So if this query is not clearly visible to you,
Ma'am,
huh?
summer and fall semester are both come under 2009 year. So can I tell you the query?
Yes.
Uh, so in the bracket, select year equal to 2009 nine, and in out of the bracket, uh, projection equal to uh, course ID.
So you are saying that here course ID should be there.
So we have to retrieve the course ID now, which are in taught in semester 2009. So
Yes, but
mm.
it might happen that there can be another semester, just like if we only going for the year equal to 2009. So this is going to list me those courses which are taught in spring 2009 also.
So we also have to means perform the OR operation in select,
Hmm.
like
So our
and
operation,
and operation in select,
okay, it's
and
and
yes.
okay. Hmm. Yes. Then which query I should write here? Which predicate I should write here? Year equal to 2009. That's done. But what about the
Semester equal to summer.
done?
Okay, and fall. Okay, which are taught in summer. Okay, done.
Hmm. Done? And what
Mm.
about the fall 2009?
Then,
Where I should pass
ma'am,
this condition?
you only write in the query. Okay, fall 2009. Then again we have to perform and like some. Okay,
Okay, this part is done.
yeah, it is done. Now I'm confused. Like again we have to pass like semester and fall of then semester equal to fall. Or
Okay, I will come to the
can
point.
we give semester equal to in double quoted summer and fall like that?
It means you are trying to say that we should go for here in bracket, or here do you think that we should write and semester equal to fall in that way?
No, ma'am. Means it is repeated, So what I'm saying, we can give the double value like semester, summer and fall by performing ending operation. Like
Yes, here problem is the same that uh, yes, that's why we are going for the union operation. Here, main point is that the two conditions, summer 2009 and fall 2009, these are based on to the same attribute. That semester is there. Right now I have given the year equal to 2009. This might happen that I may give year equal to 2010. And that's why here we cannot apply two conditions onto the same attribute. Year equal to either it will be 2009 or year will be 2010. Simultaneously both values cannot be there. First thing. And next thing is that we wanted to list those of all the 2009 year and 2010. It means both we wanted to give. And semester, this is also having a dual value, that either semester should be equal to summer or semester should be equal to fall. So if consider, instead of here and condition, if we are using here or condition, okay, or it means that here whether this is checking whether 2009, yes, that's okay, but whether this will go for fall of every year, this won't go for year of 2009. And again if I'm checking here and year equal to 2009, again this will not properly give me the correct solution. Either this will check either this condition is true or this condition is true, but we may not be able to combine results properly. That's why here we go for the union operation. Union operation, first what I will do, I will list those courses which are taught into the summer 2009, and then I will also list those courses which are taught into fall 2010 or 9, whatever year mentioned, and then we'll combine the results of the query. And that's why here we are moving towards the union operation. So let us write the query. So this query is the first part. Okay, the answer of the first part is there. So then this will be answering my first part. Next query will answer my second part. Here instead of year equal to summer, I will use the semester equal to summer, I will use semester equal to fall. And whatever the results of these two queries is there, I wanted to combine, so perform the union. Okay, output of first query, output of second query, and combine the results. This is how the union operation takes place. Whenever we are having the attribute set or condition which are based on the same type of the attributes, we cannot go for and or combinations. In that case, we always prefer to go for the union operation. So let us see the union operation, what it says. Consider a query to find set of all courses which are taught in fall 2009 semester, the spring 2010 semester, or both. Then to find the set of all courses taught in fall 2009 semester, we will use this query, that we are applying the AND operator here and we are combining. Yes, here I gone wrong. Here this is not a course relation, this is a section relation. Here you should mention the relation name very properly. Section relation is this. And then so here spring 2010 is used instead of summer 2009. So spring 2010. So for getting the all the courses of fall 2009, we will use this query. For selecting all the tuples or all the courses of spring 2010, we will use this query. And then we will combine the result by using a union operation.
Ma'am, can you increase the size of the font of query? Means it can be easily visualized to us.
So now is it visible?
Yeah, ma'am, it's visible now.
It's okay. So here, this is how we are writing the query. So I will make this as bold, if possible. Yes, now it is clearly visible. Fall and year equal to 2009 and course ID, select those course IDs which are satisfying this condition also. Semester equal to spring and year equal to 2010 from the relation section, and whatever tuples we are selecting, from that we are only displaying the course ID. And we are combining the results by using a union operation. Okay. So here again one more example is given. Sorry, this is a state difference operation. So here for combining this, combine this query. Here we will write union operation. This union symbol, and then we'll combine the result of the next query. So this is how we are using the union operation. So if course ID which is satisfying this condition will be also a part, those course ID which are satisfying this condition will be also a part of output. And also if any course ID getting repeated here also and here also, in that case only one value will be reflected into the output. Two values will not be there into the output, only single value will be there in the output. So this is how we are learning to perform the union operation. Okay, done. So okay, let us revise what we learned today. So today we started with the relational algebra operations.
Ma'am, means here the course ID and course ID in the we perform the union, then means it is repeated. So can we give add only starting?
No. Here this is a separate query.
Okay.
Okay. This is a separate query. Just like this query will also give me the output like R relation. Okay.
Okay.
Consider that whatever the query output is there, this is stored as R. And here another query. Okay. This another query will be acting as a yes relation.
Okay. Now it is clear.
Why it is displayed like this? Here this query output will be yes and this query output will be R, and R union yes we are performing, and because of which this will not give us any problem that course ID getting repeated. No, here the main thing is that single attribute, and whatever the domain of course ID is there, the same domain of course ID will be here. It should not happen that here I am asking for the course ID and here I am going for the section ID. No, that cannot be there. The domains and number of attributes should be same.
Okay, ma'am. It is understood.
Okay. So this is how we are performing the union operation. So let us revise what we learned today. So we started with the previous discussion regarding the relational query languages. Then we studied the schema, that these are the tables or relations which we are going to use during our discussion. So next we studied about the relational operations. So there can be many relational operations which we can perform by using operators, comparison operators, etc. Next we started with the relational algebra. The main theme, relational algebra is a procedural query language on which number of attributes, number of operations are done. So there can be unary operations or binary operations can be there. So first we started with the fundamental operations, select, project, rename, etc. First we studied the select operation. So select operation is used to selection of the rows, or we can say tuples, from the complete relation or from complete tuple. So this is acting as a filter to the relation. A complete relation will be given as input, and those tuples or those records which are satisfying the condition given to the select clause, which is represented by a sigma symbol, only those tuples will be given for the output and remaining will be filtered out. So here we are passing the predicate or condition as a subscript to the sigma symbol, and after that we are giving the relation name as input. And here we can combine the number of operators. We can use any number of the comparison operators, equal to, not equal to, greater than equal to, or greater than or equal to, less than or equal to, or not equal to, etc. And then we can combine the multiple operators by using connectives and or not. So this is how we are writing the conditions or predicate for the select operation. Next, we studied about the few of the examples for the select clause, select of the relational algebra, and next we started with the project operation. So project operation is used for selection of columns. All the columns may not be required for the output, and for this purpose we are using the project operation. So for selecting only those columns which are required for the output, we are using the project operation. So project operation is given by a pi symbol, and to subscript to the pi we are passing the column list which we wanted to display, where we have seen few of the examples like displaying ID, name and salary of the all instructors, or displaying ID and name of the instructors. Next we combine one more example we have studied, and then we studied composition of the operations, where we are combining the select operation as well as pi operation or project operation. Select and pi both are getting combined here. So here we have seen find names of all instructors into the physics department. So first select operation will get execute, and after select we are moving towards the project operation. Next we studied the union operator or union operation we have seen, which is represented by U symbol. So whenever we are having the conditions which cannot be expressed only by connectives, add, or comparison operators, there we are going for the combining the results or combining the two outputs by using union operator. So here whenever we are combining the results, two relations should be always union compatible. Union compatible, it means both should have the same number of the attributes and respective domains of attributes should be matching. So that is the requirement for the union operation. So this we have seen, and also we seen the example, and based on the section relation also we have seen the example for the union operation. So any doubt in this? No doubt? So okay, today we stop here. So if you are having the doubt, let me know.